In this video, we are going to see how to vary the box girder section throughout the length of the bridge. I have started a new file in SSD. I have given the name of the file, the title, selected the code and the unit set as structural engineering. I'm going to use SOFISTiK as the graphical pre-processing. I'll click OK here. Now we can of course modify the materials or we can add new materials. And then for our box girder we will use cross sections, new solid, reinforced concrete. You can go to that location from here, or you can open SOFISTiK modeling. Alright, and over here you can go ahead and add the cross section, new solid section, reinforced concrete. So once you do that, we are going to give a name over here, PSC Box Girder, and click OK. After that, let us copy the mid section, which will have the maximum number of points. So I have already opened over here the sections. I will make use of mid section, intermediate section and support section. Actually, we do not need to copy all of these three. We just need the mid section, which will have the most number of points, vertices. So I will use Ctrl Shift C, select my base point as the middle top of the girder, select my section and right click or press enter to complete the copy with base point. Now I will go back to my box section variation project file, and here I will press Ctrl V to paste it at 0, 0, 0 location. Zoom extent, and now we can see that we need to rotate or mirror this particular cross section. So I will use MI, enter, to mirror this cross section. Right click to go to the next step, and I'll press F8, click yes. Now I will go ahead to cross section editor to get the outer boundary. I'll use point in area and click inside the web or inside portion to select the inside the outer periphery of the cross section. Press escape to come out of the command. Click on opening, click point in area, click inside the opening, press escape twice and click on calculate button. Once you click on calculate button, you are able to see the points very clearly, and now we will move ahead to understand how variables can be applied. So for variables, we can use cross section properties. Click on variables and add variables over here. You can go ahead with A, B, C, D. You can use array as well, not a problem, but let's say hash A, then hash B, hash C. I already know what all variations I need, hash D and hash E. So there are 5 variations. I have created my variables and I'm going to use these variables now. I'll click OK. We'll go to the Cartesian references. Sorry. So once I am inside SOFI plus X, I can see my materials. And now let us go ahead to do the next step. In a box girder, we will firstly create the axis. Based on the axis, we will define variables for our cross sections. So we will right click on axis and say new axis. We'll give a name, let's say x01. Keeping the length as 30 meter for example. Here let's add the placements. Now since it's a box girder, there would be multiple number of placements. For example, I have already created some placements in my Excel. I'll just copy it and paste it over here. So I'll have it from mid to the support. All of these are none, only the support will have the type as support placement, and I'll click OK. Now I'll add variables. For my cross sections, I know I need 5 variables. I can name them as I wish. Right now I'm going to name them as A, B, C, D, E. So this one will be B, C, D, and E. Right, so these are the 5 variables I need. We'll come back to the variables later on. I'll click OK for now. And we will define the cross sections. After we define the cross sections, it will be more clear on what values we need to apply for the variable. You can of course provide those values beforehand, but the sequence of information is not important. So right now let's click on new solid section, reinforced concrete. We will start with PSC box section. The advantage is that you need to create only one cross section over here. We'll click OK. Yes, one more thing. In the cross section properties, you need to import the variables, all of these. So just select all of these and say add to section and close. And click OK. So now we have variables for our cross sections. All we have to do is define the cross section and apply those variables at different vertices. So first let's copy the mid section. We have mid section, import, intermediate and support section. Of course there will be several number of sections. We just need those which are majorly going to vary. Like for example, at the mid section I have 300 mm for the web thickness, intermediate section will have 500, and support section has 800 mm thickness, web thickness. So I don't need to actually provide the information in between these two. The variation will be automatically done by the program at all the divisions between mid and intermediate location. So what all things are varying in my cross section? My slab thickness or the top flange thickness is varying from 300 to 500. My web thickness is varying from 300 to 800. My bottom soffit thickness is also varying from 300 to 800. You can see over here I have a small haunch at the bottom. This is also going to vary. The height is from 500 to 0. It's flat over here. Alright, so all of this information I will provide within one cross section using variables. First of all, let's copy the cross section with a base point. Paste it at 0 position. Note that this is all in millimeters. Mirror the cross section. Now define the boundary, the outer periphery, using point in area. Press escape twice. Define the opening using point in area. Press escape twice. And let's click on calculate. So it's all good. All we have to do now is define the Cartesian references for the change in cross section. So we'll start with the Cartesian reference. First, we specify the constraint as mentioned in the command line. That means I would like to vary this point with respect to the center, okay, the top center, because I want to vary my slab thickness as well as the length. And this is right now the reference point for horizontal. I will define, or I'll click again over here for reference point for vertical. So basically this point is fixed and this vertex is going to vary. Okay, so the height is varying. Let's click on the lock and unlock it over here and put hash A. Hash A is for my top slab thickness, and this will be hash B. Note the negative sign, let it be as it is. Okay, so this is hash B, this is hash A. Similarly, I will define the variables for this point. This point is going to be with reference to the center horizontally as well as vertically. Let us change this information to hash A, the height, and this is again positive hash B. Alright, so hash A, hash B have been defined. Now we will define the information for this point. This point is also going to vary, but it is going to vary with respect to this point right over here. We are going to pull this vertex inside and reduce the distance between these two vertices. So I'll click on the horizontal for this reference, but my vertical is also going to vary, and that is going to be with respect to this point. So I will click, the second point will be over here. Alright, so that's horizontal reference and this is vertical reference. If you don't understand, you can always look at the command line. It tells you what is the next step. Okay, so here my vertical will be with respect to hash C, and my horizontal will be with respect to hash D. Again, note that the negative sign is kept as it is. Let's define for the other side because it's a symmetrical section. Click on the point to vary, the reference point for horizontal and the reference point for vertical. Click on the unlock button and put the correct variable using hash. This is hash D. Okay, so minus hash C and hash D, positive hash D. Alright, so that was about these points. Now my vertical is changing for these vertices as well. So let's provide that information. With respect to this point itself, we'll keep the horizontal distance as it is. So it does not matter which reference point you take. Of course, it's better that you take the point which is fixed. And again, I'll click over here. I won't change the horizontal information. I'll just modify the vertical data, which is my hash C. Okay, the same thing will be done for this point. Hash C. Alright. The next thing that we're going to do is vary the vertices or the position of these two vertices. Okay, these will be reducing the height. So we can simply go ahead and select this with respect to this horizontal, and this will be used for the vertical as well. We are going to vary the vertical only. So just change this -500 to #e. That's it. The same thing we will do on this side. Minus #e. Alright, so we are done over here specifying the variables. Now according to the variables, or according to how I want to change or where I want to position my vertices, I will provide the information in my axis variables. So I'll click calculate here, close, save, and here I'll go with variables in the axis, under the axis, and modify the data. Alright, so over here for axis, for variable A, you can see that by default there are all the stations or the locations of my placements, but I don't actually need to specify the variation with respect to each placement. All I have to do is tell the program that I want to vary from P1, that's the first placement, okay, then I want to make it to P13, alright, and then P14 and P15. That's it. The rest are not required, so I'll just simply select all of them together and delete. So the data that I need to provide is only for these important locations. So this is my mid location where I'll have 300 mm as the thickness of my slab. Then at the intermediate location I have 400 mm, and at the support location I have 500. Alright, so this is how I will be specifying the data for all my variables. I can simply copy this data and paste it at B as well, right over here. Just paste and delete these. Okay, specify for B. Now I have already found out the distances, so I will type them down over here. Let me also show you how I have taken the distances. So it is 2682.665 for mid location, then it's 2436.625 for intermediate, and at the support it's 2084.808, which I'll type it again for 2084.808. So how did I come to these numbers? Let me click OK and we'll go to the box girder section. Okay, so the simple thing is we have taken the distance between this point and the center. So 2682.665 is for the midsection. Then I have 2436.625 for the intermediate. And then I have 2084.808 for the support section. So this is how I have taken the distances, and I'm noting them down under my variables. So I did that for B. Now for the C, let's paste this data for placements and delete the unnecessary ones. Provide a value of 300, then it goes to 500, then 800 and 800. Then for the D, paste this data, delete this, and put up 1190, 1127.706, just the same way as I have taken the distance to 64. That's the same thing. Okay, and finally for the E, sorry, it's P1, P1, P13, P14, P15, delete the rest. Okay, and here I have E, which is 500 to 300 to 0 and 0. Alright, so these are polygonal, like straight linear variations. If you want it to be a spline, you can use this, or transition from towards the left side of the point or right side of the point, or on both the sides. So these options are there, but we are going to have straight linear variation in this example, so I've used polygon. Alright, so after this I'll click OK. Let's create the elements using line, eccentric beam, use segment on axis, click on the axis and say between all placements. Press escape. Okay, so right now you can see only one cross section when you move it around, but once you export this data, the program calculates the variables according to the length. And now let's go to SSD. So here you can see this is our mid section, and as we go towards the support section, our cross section internally inside our opening part has modified. Okay, so the thickness has also modified from 300 to 500, and our haunch also just flattens up as we go towards the support. So there could be different types of variations you can incorporate using variables. You can also get this data in the form of result table or this result viewer. So I'll just go ahead, click on result viewer over here. You can say create a new graphic, click on cross section overview. Okay, so you can see this is our first cross section. Then we can go ahead and check how the cross section varies at the end, start end of each element. Okay, so this is the last section. Alright, so that is it about how to do variations using variables in SOFISTiK. If you have any questions, please do let us know.